Okay, so in this short video, we're going to talk about absolute convergence. And we say that a series converges absolutely if the series of absolute values converges. So that's just the definition of converges absolutely, or maybe absolutely convergent. So then that leads us into a theorem. If the series of absolute values converges, then the series itself converges. And we'll expand more upon the idea of absolute convergence versus conditional convergence, which will come in a later section. But for right now, we'll go ahead and take a look at a problem where we're investigating this theorem and the idea of something being absolutely convergent. Okay, so for a problem like this, we're going to determine is it convergent or divergent. And so we'll take advantage of this idea now of being able to look at the series of absolute values and see where that takes us. So to get things started, the first thing I'm going to do is I'm going to consider the series of absolute values, and I'm going to go ahead and take it a step further just so everybody can better see what's happening. That really is just the absolute value of sine of n in the numerator over the n cubed. Since if we go from 1 to infinity, that n cubed is always going to be positive. And I think it's important to note because now when we take a look at this guy and try to determine if it converges or diverges, it's really going to balance out what happens up here. Right? Normally, sine goes between -1 and 1, but now with the absolute value bars, it's going to go from 0 to 1. And we still have our positive n cubed on the bottom. So as I make a choice as to what test to use here to determine convergence or divergence, I might consider a comparison. Because now again I know that the absolute value of sine n over n cubed compared to 1 over n cubed is going to have the inequality as less than or equal. Right, because this is going to be some sort of proper fraction at this point, meaning that this denominator would be bigger than this denominator, therefore this quantity right here would have to be larger. Now that inequality is a good one because we know that this guy here is going to converge by p series. And when I say that guy there, I'm clearly talking about the infinite series, 1 over n cubed. So that converges by p series, and because this guy here is bigger than this guy here, we can also draw the conclusion now that the infinite series of the absolute value sine n over n cubed will converge absolutely by comparison. So converge absolutely by comparison. Therefore, the original, without the absolute value bars on it, will converge by the theorem that we just discussed a few minutes ago. So if you'll remember from a lot of those previous tests, many times it started off by needing the condition that needed to be positive termed. Well, in this case, now that we have this theorem available to us, that's definitely not the case. And we can conclude because the series of absolute values converges that the initial series also then converges.